feel to it.
Yeah, it's got an almost improvisational tone.
This semester on Stat 201, prepare yourself for YouTube, because we're all zoomed out. Cahoots and special guests, Tiny Brian, Puppet Shark, Evil Moobot,
I am Mubot.
Morty the Rabbit, and more. Super Statistics Bros.
Hey everyone, how are we doing? Do we have anyone in the chat yet? It's like right as the stream starts, I have to sneeze. It's like, how does that happen? It's like stream about to start and then it's like, oh, I gotta sneeze. Hey, Riley and Dawson are here, I think. Awesome, Chloe is here. I got everyone joining in. Who all is here? We got Will and Mitchell. I'm trying to get the pop-out chat going. I forgot how to do everything. I'm off the screen. I'm everywhere. We got the pop-out chat going, and we got Mubot waking up so we can get some points in the chat. And so with that, good to see you here, Cora. Mubot is now awake. Let's talk about what I would do first. We're going to talk about what I would do, and then we're going to get into some more detail and do some practice test questions. Okay, here we go to the main screen. Let's do it. Okay. So, reviewing how to review. So I am going to do some practice test questions coming up here in a second, but I want to point this out to you. Mubot has put in the chat here, review 1 videos. And what you want to do is you want to start early. Now, what I would do if I was you is I'd go to this playlist right here, and I would start, this is 5 minutes. Chapter 2 is 15 minutes. Chapter 2 topic right there is only 3 minutes. That's 3 minutes. This does shape center spread right here. It's a little caption from class, shape center spread, talking about the metrics we use versus mean versus median. You got all these little mini videos right here. You got a chapter 3 speed run. Doesn't cover everything, but there's mosaic plots and continuous tables. Well, mosaic plot is right here with marginal and conditional distributions. Now, here's what I want to point out, and it's all right. You want to start early and you need to write down your plan. Who has a plan written down? Who has written down a plan on what they're going to do right now? Who has their plan saying, I'm going to do, and if you do the practice test, I got videos going over how to do the practice test. So if you go to the practice test right here, you will see videos. You're like, how do I do this question? A full walkthrough of the question explaining everything. Who's got a plan written down? Z-scores and the empirical rule. Look at that. And then you find right here the areas between such and such and such and such. I don't even know what I clicked. Anyone in the chat got a plan written down? Who's got a plan? We're going to throw out some points. We are streaming, right? Well, this is recorded. You got it. This is actually perfect. I was just about to start saying, Dawson, good to see you there. We're going to start some questions coming up here in a second. This is recorded. So what I would do is these videos walk you through. I guess it's officers. In-person officers. These videos walk you through step by step how to do the practice test problems. So do not wait till the night before your exams. I know it sounds crazy, but you want to start studying for an exam about a week in advance. You're like, what am I doing? It'd be like saying, I'm going to lift and I'm going to start lifting the night before a competition. I don't do competitions, but you're like, I'm just going to lift the heaviest weights. I'm going to do it the night before and get super strong. No. You need some time. You need to put in the time, you need to put in the effort and get stronger over time. So use these videos, use the review test, use the review material, all found on this page right here. Now let's get to some questions. Okay. The big chapter people get stuck on is what chapter people have problems on. We're going to put this in the notes. Hey, Jaya, good to see you there. Jaya, good to see you. If I mispronounce anyone, please let me know. But with this, what chapter people get million notes? Chapter 5. Let's put right here in the notes, chapter 5 review. Okay, good to see you there, Jan and Tamara. Chapter 5 review. You say, Brian, I know. I got those videos. Well, so what are the numbers you should know? I've got some more complex numbers on the screen. I'm going to save this real quick. But I've got some more complex numbers that you don't need to know. You'll see it again here in a half second after it saves. It's saving. There it goes. What are the numbers you need to know that will be shown to you on a problem? 68, 95, 99.7. And if we use the applet, it does more exact versions of this because there are. Good to see you, Riley. Let's throw some more points. Got a bunch of people here. So they're really. Okay, it's possessed. It's haunted. That one's haunted. 68. 95, 99.7. Those are the numbers you should know. And let's start off with a nice and easy empirical rule question. I'm going to throw you 3 of these. I want to see if you can solve them. Okay, so here's the question. And when you do a test question, it will usually do the following. It'll say, use the following to solve. Okay. Harrison, good to see you there. Do you notice that this question is telling you to use this to solve? If you see this, do you know what you should do if you see this on a question? We have test questions that say this. Good to see there, Riley and everyone. If you see this, what should you do? We're about to write 3 questions here. I'd be happy to get 6 minutes. All right, that's the first question. Draw the curve. Yes, draw the curve. Draw your curve to start the test, actually. And this right here, someone might even know this answer immediately. We'll draw these out. Who knows? You can start answering these if you want. We'll go through each one of these. This is empirical rule questions. Okay. Who's got answers to these? Feel free to start drawing it. Will we have access to the website that we use? You won't use the website. Nope. Good question, Dawson. Let me throw you some points. This is one version of the questions you might see. So I'm trying to mimic the test right now. And this says use the empirical rule. Who has answers to any of these on the screen? Try doing it. See how many of these you can get. We'll start taking some answers, and then we'll start drawing it out. So I can start working what I would work if I had this problem. Ooh, Dawson, reverse it right there. I think you're on the right track now. This was a fast race. And remember, faster means times are lower. I think that could cause confusion on this, and we'll draw it out. Dawson, let me throw some points. I think you know where to do. Like, you get what I'm saying? Like, instead of going down, going this way. So, let's go right here. I can be confusing things with running times because faster means lower time. So I think Dawson might update their answer right there. So we draw the curve. And with the curve, what we're going to do is we're going to put at the center of the curve 530. Then we're going to go up 1, 2, 3. Yeah, Dawson. Dawson's on the right track right there. See if you can solve the other ones, everybody. I'm going to be drawing this. This is what you should be doing to solve this question. So this is 5:45. This is 6 minutes. This is 6:15. Now, what do we also put below this curve? We put the actual context on the curve. And then what do we also put on the curve? So if you notice right here, the mean goes at the center of the curve. That's where the mean is at. And then the distances by which we go up are going to be the standard deviations. So what do we also put below the curve? We put another thing below the curve. So when you're drawing the curve right here to help you out, you should also put, ooh, Riley might have the second one. Good job, Riley. What else do we put? It looks like people got answer 2. We put the z-scores. Riley knows right there. You draw the z-scores to help you out to see what the standard deviations are. A lot of people know them, but it's just good practice, and it might reveal some answers. 22? No, that's not what that is. So there's the z-scores. This is the z-scores. This is the context. The context means like the actual running times, and there's the z-scores. Virginia, good to see there, and good practice, or good to see here. So now when you do this, what you want to be thinking about, where is Brian? Well, Brian is going to be here at this blue line. And then when we think about the runners faster, it would be down here. So the answer to the first question, as a lot of people are getting, is if we go and do the 95% between -2 and 2, you'd have 2.5% above. So mathematically, put the math in the chat for 500 points. There are 2 ways to do the math right here. You can put either of the ways. The 2 ways to do the mathematics are either going to be that or using this and subtracting. So there's 2 ways to do the mathematics to get the answer. And once again, this is 95% between -2 and +2. And good to see there, Jasmine right there. Jasmine. And so how do we get the mathematical answer? Just practice, and people can see it in the chat. Really good practice. Like, write it down, be like, okay, 95 in the center, 5% on the outside, 2.5 on either side. So you could just take that out of what? I mean, that's one way. Because then it's the area below 2. See if anyone puts in the chat. Some points. If you're talking, you're practicing. You can always say, I don't know, and then I go into more detail and solve it on screen. Adeline, good to see you there too. This is one possible question using the empirical rule, just the way it goes. Well, does anyone know? We'll get the points by answer. I know the answers. It will be a good way to do this is you could just add the 2.5. And if you don't know how to do these, let us know. Just say, I don't know how to do this. Great question to ask. You could just add these two numbers and get 97.5 for the first question. So the first one is going to be 97.5. You could also subtract from 100 and get that. How do we get the next one? Where do I need to mark on the curve at a z-score of what for the next question? On the curve, mark it as z-score. Am I frozen? Oh, something weird happened there. Oh, there we go. Where do I have to mark on the curve for the next question? At a z-score of what? What is going on? -1. Dawson getting us some more points in the chat. The z-score of -1, which can be seen right there. And it says we're faster than this. So I think, we might have had an issue. And what percent of runners were faster than 5:15? So what is the answer when we look at the percent of runners faster than 5:15? So be careful. That is correct right there, Virginia. And Dawson has the next one for us. And great job, Jackson. Also, good practice. We have to go here and do 68, which is the first number. This stands for the 1, the 2, the 3, respective to the z-scores. And now we say there's 16% above here, or we could do the 16% down there. So the answer to the second one is 16%. Once again, it's way easier when you can draw the curve. When you draw the curve, it's way easier. The next one, we simply mark the z-scores again, and the next one's not too hard. What is the next one's area? There's quite a few ways to do this one. If you remember some of the numbers we did earlier. Oh, number 1? Yeah. Let me do number 1. I'll explain number 1. Good question. Please, as we're doing them, just say, how do we do them? So what you want to do is, especially for this one, this might also answer number 1, is if you think that there is 68 between here, which is the first number, right? And there's 95 within here. Who follows me here? Does everyone get this? How much is this? We're going to draw the arrow in purple. How much is this purple arrow worth? How much is that purple arrow worth? It's half of the remaining 95. And Dawson's got the right answer. Great job, Dawson. How much is that purple arrow worth? And we'll talk about number 1 again. How much is that purple arrow worth? 2.5. Does everyone see it? How much is this new purple arrow worth? Because that's outside of the 68. So how much is that other purple arrow worth? How much is that other purple arrow worth? The bigger purple arrow. How much area is underneath this? That's what we're saying when we say how much is it worth. 16, you are correct. So think the area highlighted in pink is the area we don't want out of the total. So what could you do mathematically? There's a lot of ways to solve this. But what could you do mathematically? Because you want the area in the center. You don't want the outside area. There's 100% of the area. So write an equation in the chat really quickly, if you can. And there's a lot of ways to solve it. Someone might have also known that the area between here and here is 13.5. That also solves it. What would we do? What would we do? Because this whole thing's worth 100. So you don't want this area and this area out of 100. And that will solve it close. Well, the whole curve is worth 100, right? And Tamara doesn't. Good answers. Oh, wait. I think, Tamara, that does it too. A lot of people are doing Jackson and Tamara and everybody. Let me throw you some more points. That is correct. There's so many solves for this. I was thinking of 100 minus 16 minus 2.5, or you could actually add those. So you could say we don't want this area out of 100. Does that make sense? So there's so many solves for this one. That might be one of the tougher ones. Tell me if you don't see it, but lots of different solves. So let's talk about the first one again briefly here. On the first one, you should first find the what for Brian's time. You should first find the what for Brian's time. Here's Brian's time. You should first find the what for it. Just the steps you would do to solve this. You should first find the what for it, the z-score. Now we're going to use one of the empirical rule numbers, and we're going to plot faster than. Faster than means we need to shade below Brian's time. If people are faster than you, they have a lower time. That's the way faster works. I know you might think faster is in higher, but no, it's going to be lower time. Now we write down the 95 number for the empirical rule, and we take the outside remaining area. So there's two mathematical ways to get the answer of 97.5. What are the two mathematical ways to get the answer of 97.5? Because 68 is associated with 1, 95 is associated with 2, and 99.7. Riley, thank you for asking. 1,000 more, Riley. Keep asking. We went to 95 because that is the second number in the 68, 95, 99.7 rule. And they are associated via what number they are, 68, 95, 99.7. Tamara might be doing the last one there. Good job, Tamara, on the last one. So how do we get the answer here of the shaded area in blue right there? The shaded area in blue, which is runners faster than Brian right now, the 81.5 was found by adding up the 68 plus the 13.5, or 100 minus the 16 plus the 2.5 right there. And Riley sees it. Riley, is it making more sense? It's a lot of practice of these. And maybe we'll do another round of this because I know people are asking more questions. Really good work. We'll do the last one here. Maybe we'll do another round. Jan, good questions. So the last one here says, what percent of runners are slower than Brian? Okay, now let's do it in steps. The thing here is to learn the steps. William, good work. So the first thing we're going to do with the 4.45 is find its what? Remember how to do it in steps. Virginia, here, I can show that too. And you can, so what are you going to do first step? And actually, Virginia, this would answer it. The first thing you would do with this is do what right here? The first thing we would do, this answers the previous one, is find what? Find the z-score. Does that make sense? So this is 45 seconds over 15 seconds. It's negative 45 over 15. And then we can see visually that this has a z-score of negative 3. And that goes to Brian's time also. Does that make sense, Virginia? That you want to find the z-score. And that goes the same for Brian because Brian is 2 standard deviations above the mean, and thus he has a z-score of 2. So now that we found the z-score here, it says slower, left or right, slower, left or right, slower. Do I plot left or right of it? Slower, do I go to the left or to the right? Which way do I plot? Which is slower? To the right, because slower would mean higher times. To the right. Good answers, and don't worry if you get it wrong, we're practicing. If you get it wrong, that means you're learning. That's where you get the points. So we know we need a big or small number. We need a big number, right? It's going to be a lot of the area. So this is the area we're not using. And we have 99.7 because that is the number associated with 3 up here. And that leaves 0.15, or yeah, there we go, 0.15 on the outside there and 0.15 on the outside here. What are the 2 ways to get the answer for the blue area? The 2 ways to get the answer for the blue area are to do what and what? The 2 ways to get the answer for the blue area is to do what and what? The 2 ways. The 2 ways. 2 easy ways. There's a bunch of ways. Nice job right there. Emily on fire. We're throwing Emily 1,000 points. That's right, Emily. And there's a way to like add up even more areas. Like you could add up 0.5, 2.35, 13.5, 34, 34, 13.5, 2.35 is add up too much. Well, now we're getting the area, and the area is going to be, as Emily put right there, we're either going to add together this 99.7 and this 0.15, or we're going to subtract this out of 100 because take from the total and find the remaining on the other side. So take your vote right now. Do you want to do Applet questions? We've got a little bit more time right here, and I will be here for office hours later. We're ending the vote in 5, 4, 3. Vote in the poll. 2, 1. It's a close vote. Watch it be a perfect tie. We'll do whatever the poll says. It is Applet questions. We might have time for more empirical rule ones. So with the Applet questions, okay. Will you be using the Applet on the test? Will you go, let me put right here, Applet questions, empirical rule. Will you be using the Applet on the test? No. So chapter 5, review, Applet questions. Is the test set up like multiple choice, fill in the blank, true, false? Test 2 and 3 have entry, type in questions, just like Canvas content. Except for Canvas content, there's no type in questions. But test 2 and 3 do. So that's the little change up. We will have pictures of the applet. You know it right there. Cora, good to see you there. And Megan, good to see you. So you're going to have pictures of the applet. So I have to make some pictures right here for you. And let's start off easy. We're going to start off with a very easy question, I would think. And don't worry if it's tough. We'll start off easy. We have a test, and the test has a mean of 70. And the test has a standard deviation of, let's say, 10 points. And then we're going to say the following. This is meant to be an easier question. Don't worry if you miss it. What percent of students scored below an 82? What percent of students scored below an 82? And I'll draw it out here in a moment. This is your first question. What percent of students scored below an 82? I'll start screenshotting and drawing here. That's snipping tool, right? Canvas content quizzes are great. Yeah. They're meant to look like the test. We purposely created them to give you experience of using the test. That's why we created them. So you would say use the pictures below. And what percent of students are expected to score below 82? Okay. When you get an applet picture, the first thing you want to do is start drawing on it. And Emma's got it right there. 1,000 points. Emma immediately getting it. You will be using Proctorio. That is correct, Dawson. Thank you so much. Good questions. If there's problems, please let me know immediately. So what percentage of students expect to score below an 82? Now, this one is so easy. You don't have to do a lot of work on it. But what I would do immediately is start putting your z-scores. If I didn't know this question was so easy, I would have put z-scores below it. And then I would have went here and I would have said, this is where an 82 is at. And this is 12% of the area. And that's what the curve is showing us, that 12% of the area is above 82. Then I would also graph the answer. And mathematically, how are you getting the answer? Who can mathematically explain the answer right here? Because now we're visualizing the answer. Because it wants below 82 in the question. The question says, what percent of students are expected to score below an 82? You can use calculators as long as they don't have internet capability, so don't use your phone, things like that. And people are saying it's just 100 minus 12 because the whole curve. And once you can visualize the answer and see it, it's a little bit easier to be like, oh, that's 12%. We're looking for the other side of the curve. So it's 88%. Be careful. This is a score of 82. This does not mean 82%. That's why I put the percentage down there. Nope. We would, every applet picture has enough information to solve the question in full. Colin, good to see you there. 5,000 points from Disney. Who loves Disney? Say your favorite Disney moment or favorite Disney movie in the chat right there for Colin. Calling in from Disney right there. Colin, I hope I never mispronounced your name too, even though I've known you for, 2019, right? Colin, we've known each other for 6 years, over half a decade. So shout out to Colin right there, making his dream come true, working at Disney. So really awesome to hear from you at all times and seeing you swing by. So 5,000 points. Shout out your favorite Disney movie, favorite Disney anything in the chat. Shout out to Disney. Disney is awesome. So now we're going to make, no, you're in your 20s, man. I'm in my 40s and not even like early 40s anymore. So don't worry. You'll always be, you could be 40 and I'll be 60 when you're 40. Anyways, next question. Fine. Moana's great. What percent? Here we go. Here's a tougher one. You ready? Okay. Here, William. Okay. What percent of students are expected to score above a 68? Now, here's what Mubot just telling jokes in the chat. Here's what you should do. Okay, so whenever you get a number, what should you do with this number? We can still solve this question. So we've changed the question. What do you think you should do with 68? Who has ideas? I need ideas in the chat because we're trying to solve a more difficult problem now. Any ideas, any thoughts on what you should do with 68? I cannot get my mouse speed right. What should you do with 68? Find the z-scores. Find the z-score. Okay, so we have to find the z-score of 68. So if you get a number, you don't know much about it, you should turn into a z-score, which is z-score equals observation minus mean. I prefer to use mu. Observation minus mean over standard deviation over z-score. Why not? Let's z-score a z-score. That'd be meta. Then here we go right here, and it's negative 1.2. Okay. So negative 1.2. Now, what are we viewing on the screen right here down below? 82 is currently marked, right? 82 is currently marked. What else could we do with 82 here? What could we do with 82, which I'll start doing in the background? What could we do with 82? You're seeing me do it right now. What could we do to 82? What could you do to 82? Find the z-score. What's the z-score of 82? Go ahead and solve it. What is the z-score, and then what do you notice? What is the z-score for 82? What is the z-score for 82? You have to solve that equation right there. Observation minus mean over standard deviation. Standard deviation is 10. The mean is 70. And you can see the information on the curve where the mean is 70, standard deviation 1.2. Now, what do you notice about 68? What do you notice about 68? What do you notice about 68? What is something like, huh, isn't that neat? You notice about 68. Here's where 68 is at. Has z-score of negative 1.2. And this has z-score of 1.2. They're opposite z-scores. So what's the answer to the question of students who score above a 68? So we want the percent of students who score above 68. Does anyone know the answer to that question? Grav? Oh. Dawson. I feel like I'm Shia LaBeouf. Shia LaBeouf, you never know. He could just be right over there watching. Shia? I don't know. Even Stevens, right? So it is going to be, the answer is Dawson got it right there at 88. Let's show it visually. So what you could do is this area of 12%, which is currently shaded, is this area over here, right? Does everyone understand that this area right here is 12%? That makes this area 12% here also due to the law of symmetry. So now if we start editing our graphic a little bit, we can just say, well, if we have 12% on that side, then we want this area above it. And it's the same math again, if you can't tell. I mean, we just literally did the same question with one more step.
It doesn't matter.
Who thinks they follow this? Yes or no, do you follow how we solved this one? You had to z-score everything, and then you can kind of see it once you z-score it or you start graphing it, and you're like, oh, it's just 12% on the other side, and then we're just going above it. And the above area is 88%. So that's just an additional step. So we've noticed a trick right here, that if we start z-scoring things and we start labeling our curve, and Riley, you bet we're doing another one. Riley, 1,000 points right there. That was my plan. And then I'm going to keep upping the difficulty. It's just progressive overload of our stat muscles. We just get stat strong. That's what we do here. We learn how to do these problems, say these aren't hard. Just z-score everything. Testing my knowledge, I get, but why is 68 not to the... Oh, because we're not exactly at it. In Jackson, good question. We're not doing the empirical rule right here because the z-score is not what? Why is it not 68? Someone answer in the chat. It's because we're currently not at a z-score of 1. I just said it. Dang it. I was going to say what? The z-score is not 1, so we're not on the empirical rule 68, 95, 99.7. We're further out, so there's 12% in the tails. So this is not a 68 rule. Yeah, good question, Jackson. I'll show you some more points. Keep up the questions. This is not empirical rule. This is further out than 1. We're at a z-score of 1.2, which would have more than 68, but less than 95. So you can kind of use some of your empirical rule knowledge to also check these answers. So good work. Great job. Let's do another one. We need to get another picture. I am going to make this one more difficult. All right, here is a more difficult one. And now let's go here. Okay. The context is going to remain the same. And the question is, what percent of students are expected to score above a 66? So Let me write the context if you don't remember it. No, not 66, 76. Okay. You get a graphic like this. I'll learn eventually. What are you going to do to this graphic down here? Tell me your first steps and first thoughts. I'm training you how to do these questions. It's not about solving it. It's about the training and what you think when you see this. It's about the training and what you think when you see this. Like you should know what you're seeing on the bottom right now. You should know on the bottom I'm seeing what's currently. And they should think another thing. Like, what are the steps to solve this? Yeah, and Emma, you're on there. You got it. What are these currently? Emma's got it. Emma's saying add to it. I wouldn't change it. I would just add to it, right? I would add to it. So I wouldn't change it. I would just add to it. But Emma's right. Like, we want some context here of what the numbers are. And what you see currently are the z-scores. So you currently see the z-scores. Does that make sense? So we usually find z-scores a lot of times, but we currently see the z-scores. And then what is this right here on the graphic? This is a what? Tell me what this is, which don't worry, repeat if you have to, but that is a what? That is a what? That is the z-score. So we need to take that z-score and think of an O word. We have to take that z-score and turn it back into a what? That is a z-score. Because that is the z-score for right here. That's the z-score for right there. So we have to take that z-score and turn it back into a what? Think of an O word. Don't worry, keep answering. Turn the z-score back into a what? Because usually we go from this to a z-score, but now we're going to go from a z-score back to this. Think of an O word. It means observation. Does anyone know what the observation is? Does anyone know what the observation is? What is the observation? It's 84. Emily, you're on fire there. It's 84 because you just go to the mean, and then you go z-score plus standard deviation. So it's the mean of 80 plus the z-score of 0.4 times 10. And since the z-score is since the standard deviation is 10, it's really easy. And that gets you equal to 84, which is where this is at. This is at 84. Now, what do you notice? How do you know the mean 80? The question would say, Oakley right there, good to see you. The question states right here, thank you for asking. The question states, and I don't think, thank you so much. Oakley, we're throwing you 1,000 points. You might have joined in, and I had already put the mean down here and written it out. But thank you for asking. That's where the question gives the information. Good question. Because if you didn't see that start, you'd be like, wait, how do we know that? Good question. And thank you, everyone, for helping out. So with this, what do you notice about 76? 76, maybe we should what 76 now, which maybe we didn't even have to the first part, because now when we what 76, we're going to see something. I'll start doing the process with 76. There's the process of observation minus mean over standard deviation. Find the z-score, and what do you notice? 76, which is what we're looking for here. 76 is down here. And this is 0.4. This is negative 0.4. This, if you can solve this question, this is one of the tougher ones. Like, this is of the higher difficulty levels. So what's the answer? Does anyone know the answer at this point? You can probably see it if you know the steps from here. Does anyone know the answer? I'll zoom in. I'll disappear. See if you can get the answer to the percent of students who are expected to score above a 76. See if you can get the answer. Tamara, 1,000 points. Tamara got it. Trying to walk you right up to the answer, and then hopefully you can see it. What I would do is I'd then realize that since this is, we'll write it in black right here, this is 34%, which makes this 34%. Since it's symmetric right there, that has to be 34%. And then we're going to erase this because we just don't want to see that anymore, even though we were using it a moment ago. We're going to erase that right here. And then if we know that this is 34%, we just do what? What did Tamara do as her next step right here? If this is 34%, then how did Tamara get the other answer that is 66? So what did Tamara do to get the 66%? I think it's a little bit obvious when you see this. Exactly. And definitely this is recorded, so I try to do a bunch of these so we can do more. Let me take another poll. We got a little bit more time. I think my office hours start at 12:45. So I thought about doing just online today, but 84, do we need to find that? Oh, the empirical or applet. We can do more applet or empirical roll. The finding of the 84, we kind of didn't have to, but I would suggest to the question right there, Bridget, good question. If I have an observation, I'd turn it into a z-score. If I have a z-score, I'd turn it into an observation. Does that make sense? It never hurts to know both things for each one, so that if you have the observation of 76, you know it's z-score. If you have the observation of 84 or the z-score of 0.4, you know it's observation. Does that make sense? And then you should be able to see here visually on the bottom that this is about at negative 0.4 and this is at 76. Is that making sense? Like when you graph down to it, you would see that hits at negative 0.4 and that also hits at 76. And then you would see over here 84 hits at a z-score of 0.4 and you would see the symmetry then. You'd be like, oh, it's just the other side of the curve. So turning things into z-scores or observations, just having both and drawing both can usually answer a lot of the questions. Applet questions are winning out. First person to say, you're welcome. First person to say easy, medium, or hard, take your pick. I will throw whichever one you want, so it'll be at the level you asked for. Or you could say like ridiculously easy. We'll do easy, medium, hard. What do you want? First person to say it. Chat may be a little bit different when I see it, but first person to say easy, medium, or hard. We will pick. It will make a question. Medium. Let's go for a medium question. Everyone's saying medium. There's agreement among everybody. Okay. Let's say IQs are normally distributed with a mean of 100. A standard deviation of 20. And I'm trying to do a different version. Last one was hard. Ooh. Okay, I got a good one here. Thank you, Emily. Emily, I'm making a question off this, okay? Good question, Emily. Okay, so here we go. To Emily's question. The question reads, I don't think we've ever written one like this, but I'd say it's a medium difficulty. The question reads, what is the IQR for IQs? So this question says, we could do a quick solve on it too. Then we do more questions. Use the re-enrolling. Use the graphic below to find the IQR for IQs. IQR for IQs. Okay. So what do we see? Let's just first take in the graphic. You ready? What do we see? IQs have a mean of what? IQs are normally distributed with a mean of what and a standard deviation of what? We'll write it out here. IQs are normally distributed. And the first number is the mean. Next number is the standard deviation. So what do IQs have? IQs have a mean. IQs have a mean of what? IQs have a mean of what? We just see it. The graph is drawn. 100 and a standard deviation of 20. And then we go right here. And on top of this, we're also going to see that it is normally distributed. And that's what the capital N stands for. Not population. Population is also capital N in statistics. But does everyone see how this notation works? Good job, Corin and Riley right there and Emily. Normally distributed with a mean of 100 and a standard deviation of 20. So that's what that means down there. So you can draw out the curve. So now we have to think about what we see. We currently see the what for IQs. Ooh, come on. The IQR, typo, ignore the typo. We currently see the what for IQ, which also leads to another good question. That's an easy question. We currently see the what for IQs. We currently see the what for IQs. Yes, when it says use empirical rule, use empirical rule. Good question right there. When it says use empirical rule, use empirical rule. We currently see the what for IQ. What is this? What do we currently see on the screen? This question is easier than you think if we do a lot of ways to solve it. Close. Emily with 30,000 points. It's not Q1, though. Where's Q1? Good answers. I'm throwing another points on top of this. It's not Q1. Say, Brian, Q1 is the 25th percentile. Yes, it is. It is Q3 because Q3 is on the right side of the curve. So what percentile is this? This is the what percentile. This is the what percentile. This is the what percentile. It's also known as the top 25%. This is the 75th percentile. So that's the 75th percentile because 75% of the data is below that. Know that for the test. Percentile means area below a point. Below, not that like that's a test question or anything. Area below a point. Okay. So we know percentile is area below for the test. And with this, let's think, has anyone figured out the answer to this yet? You might be able to solve the answer like that. Does anyone have the answer? Any guesses on the answer? I'm going to give it another few seconds and then answer it if no one does. I think my pen lost this point. So, the IQR, what is the IQR? So what do we need to do? Like, what math do we need to do to find the IQR? When it says find the IQR, you think, like, you're going to think math for IQR. You'd be like, what is the math for the IQR? You'd be like, how do I math the IQR? It's not 50. Good guess. Not max. That's the range. The range is max minus min. The range of the interquartile range. We could z-score it. We could do that. We could do that. Emily on fire. Emily is correct. Great job, Emily. Emily got it right. It is Q3 minus Q1. So it is Q3. Really? What's that? Q3. Really? Minus Q1. Let's see how Emily found it right here. So Emily, I think I know the solve you might have done. Maybe you did this solve. What I started to think as we did this is the IQR, when you think about it, is going to be this distance here. And then also, it would be down to here. And it would also be this distance here. Who follows me? Because that's where the bottom 25% is. I didn't draw nice and neatly up enough. It's going to be right here. There we go. That's better. That's better. Gotta look right. Okay. So, that's no Jackson. Jackson plays some points. That's all right. So if you think of one of these distances as x, the total distance here is what? If one of those distances is x, what's the total distance? If one of those distances is x, what's the total distance? And this is at 13.49. If one of those distances is x, it's 2x. Who follow? Just tell me if you don't follow it. Because you're just figuring out how much we're trying to find out this distance right here. That's what we want to know. And what is this distance right here? How much is this distance in light blue? How much is that distance in light blue? Because it goes from 100 to that. So what is that distance? I mean, that's right there, because it goes from the mean of 100 to that value. 13.49. Boom. So then what's the answer? So that's 13. We try to write it in here. That's 13.49, and that's 13.49 because it's symmetry. There we go. You could have also found the 25th percentile. You could have z-scored these things. There's many, many ways to do it, but they're equal distance. They're x, so this has to be 2x. So 2 times 13.49. And then what's great, if you come up with your own questions right here, you can use the Applet to confirm answers, to go to things and do like the middle 50% and go to between. What in the world's going on right there? There we go. The middle 50%, you could just subtract these two numbers right here to get the answer we got. Which part, Riley? Which part are you wondering about? The question states in Riley, good questions right here. The question gives us this value right here of 13.49. That value of 13.49 is given for this spot right here. and then we subtracted from 100 to get the distance right here, because 100 is the center. So we found out how far are these two numbers away, which is a distance of 13.49. Tell me which number you're confused on. And Raleigh, thank you so much for asking. Then we'll try to do one or two more maybe. Like the 13.49, the 113.49. This is where the bottom 25% is. This is where the top 25% is according to the problem symmetry. 113.49, and then we're subtracting from 100. Yeah. And then we because when we subtract from 100, all we're getting is the distance from the what percentile to the what percentile. So follow me on this. When you subtract from 100, you're only getting the distance from the what percentile to the what percentile. When you subtract from 100, you're only getting the distance from the what percentile to the what percentile. Just tell me percentile-wise, when you subtract from 100. So when you go 100 minus this, I'm trying to draw it differently, and then you do 100 minus that number, you're going from the what percentile to the what percentile. Great job, Bridget. Yep. And does that make sense? That might help to see it this way. It's less numbers on the screen. And now what you're doing is when you find that answer right there, that distance you're just taking, and then you are just doing the opposite on the other side because it's the same distance here. And then you're also taking that and doubling that distance because it's the same distance right there. Does that help? Let me know, Riley, if this makes sense. But so you would subtract those and get 13.49. And that would be 13.49 this way because it's the same distance. And you would just add together these distances, which are both 13.49. 13.49. Yeah, this might have been medium difficult. If you found this difficult, it's hard to like hit a medium question. It's hard. It's like, you don't want to make it too easy. You don't want to make it too tough. But that was a decent one. I like it. Okay, let's do another one. Okay. Easy, medium, hard. You want to do an easy one? I think my office hours start at 12:45. Yeah, 12. We got a lot of time. Did my sister messaged? Wait, what's this say? Let's see what my sister said. What does it say? Yeah. Easy peasy. Okay. Okay, easy question. All right, you ready? Let's use percentile. Something's off on that. Wait. Oh, below. Okay, easy question. What is the IQ of the 90th percentile? What is the IQ of the 90th percentile? What is the IQ of the 90th percentile? So if you solve it, let us know. What is the IQ of the 90th percentile? So what do you see on here? Just start to take in what you see. This is meant to be an easy, non-multi-step question. I mean, there's like one or two steps to it. So I guess it is multi-step, right? What is the IQ of the 90th percentile? I believe that is correct. Dawson got it. And hopefully, like, this would be an easier one because currently we see the IQ of the what? It's like easy, medium. It's like a level 2 or 3 question out of 10. Right now we see the IQ of the what? Like, you always want to take in what you see. I currently see the IQ of the what percentile. So remember, IQ or percentile is area below. So you take in what you see and you say, okay, I currently see the IQ of the what? The 10th percentile. Great job, Jan. Jai right there. You see the IQ of the 10th percentile because 10% of the area is below this data point right there. And the IQ of the 10th percentile is a 74. So when you think the IQ here is 74, then that actually has a z-score of negative 2.6 if we z-score it. No, it's not negative 2.6. What am I doing? 1.3, right? I think it's negative 1.3. We could double check the z-score, but I believe it is 74 minus 100 over 20. And that's going to equal to, yes, negative 1.3. And then when we ask for the 90th percentile, it's the top what percent? The 90th percentile is the top what percent? The 90th percentile is also known as the top what percent? The 90th percentile is the top what percent? Top 10%. Mm-hmm. So what we want to do is go to the center, and we could say this is how far below, and then tell me the mathematics. So if you figure out this, you should see the mathematics now to find the answer. We are interested in this answer right there. So how are we going to solve it? Loud horn outside. Where'd that be from? How are we going to solve it? What would we do? Yeah, Dawson, nice work. Dawson's showing all the math. Yep. And you would just go right here and do 100 plus 26, add those together, and you can get the spot over here. And you can also kind of see where it's at. The better you draw it, the better the answer is going to look. Like this is 126. So that's what you want to do. Does that make sense? Like if you do a good drawing, you should be able to see that it's about at 126. It might not look perfect, but it's going to look like, yeah, that's about at 74 because 70 would be in the middle. And that's about at 126. We might not have drawn it perfectly, but the better you do the drawing, the better you can get the answer. What additional questions do people have? What additional questions? We could do another one. I'm like calluses on my hands. You can actually, whoa, can you see them? You can. Wow. Dumb question. Where'd you get the 26? No, it's not a dumb question at all. The 26 is found howly. Howly, how are we getting this? It depends. It depends, Jackson. A lot of these, just keep solving them. The 26 is found how? Think about it's the 26 is a distance down here. So how are we getting 26? Yes, Riley and Adeline right there. And people, I think people are seeing it. Like you just start to see it. I ask you to see it and other people to type it. You're just acknowledging it. And here's the thing. If you can't get your students talking, I tell this to educators, they're not learning. It's like when you have a conversation with your parents and you just go, uh-huh, mm-hmm. How would you feel if your partner, if you were just talking to them and for like 30 minutes to an hour, imagine an hour-long conversation where the whole time your partner just goes, mm-hmm, mm-hmm, mm-hmm. What would you think? What would you think? That's what I tell other educators. I'm like, you have to get them talking. You have to get them talking on day one. If you don't get them talking, they're not learning because they're not thinking about it. There's so many distractions in the world today. You have to get people talking. You have to get them engaging. And so I'm really honored and proud that people are in here typing and engaging, maybe drawing it out, writing it down. If you're drawing it down, if you're writing it out, you're engaging. That's not really talking, but it's still of the same essence of thinking it through. I mean, if you're talking to someone and they're writing things down, they're listening. But if you're talking to someone and they just shake their head yes the whole time, they're probably zoning out. They're probably not thinking about it. What additional questions are there? What additional? Should we do one more? We got a little bit more time. I will be doing in-person office hours. I'm hoping people show up. I feel like I should have said, like, today is completely online and did a big stream and did every chapter. But we could talk about checking normality. We could talk about some chapter 6. What do you want to talk about in our last 10 minutes here? So that was all the Applet questions. We just did Applet questions for like 34 minutes. Yeah, we can do more of these during office hours later. We can do whatever you want. We can do whichever questions. And thank you for coming by office hours. Feel free to just ask anything right now. I might try to eat some lunch here in a moment, maybe. My wife made me lunch. My wife made fresh bread. I get a fresh bread sandwich. We got one of those KitchenAid mixers, and you can hear like making the dough being like, blah, 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 kneading the dough. Empirical roll? Oh, let's do an empirical roll one to end. I'm just thinking about fresh bread right here. W wife, she is the best. She is. I made a card for her best wife ever, and I mean it. Office hours later will be at about 2:30-ish. They'll be in between my BAS 320 class and the in-person office hours. Swing by in-person office hours. You can come in. We can work questions. I can draw them on the board. Let's do another empirical question. I think I get a peanut butter and jelly sandwich with fresh bread. Empirical question. Okay, empirical rule question part 2. So if you see the following in a question, what do you know you should be doing? If you see the following in a question, you will be using the empirical rule. So IQs have a mean of 100 and a standard deviation of 10. Answer the following questions below. Not 10. Okay, so pro tip. Before the test starts, draw out what? Before the test even starts, sorry. Oh, well, you should do it before it starts. You cannot bring notes to the test. Please, pro tip, you can't bring notes to the test. When the test starts, sorry, need more coffee today. When the test starts, draw the normal curve. So the normal curve with the empirical rule, these numbers are called the empirical rule numbers. They are rounded. It's 68.26, 95.449, and 99.73002. And this drawing right here, ooh, really pretty drawn. Hope it copies over really well. This is, you can't bring this to the test or anything like this, but this is what you would want. This is where the numbers come from. You can crop pictures right here, make them look real pretty. And now, when you draw out the curve, you should also add your what to it. You cannot bring notes to the test. You cannot bring notes to the test, but you can start the test by drawing something. Once the test is started, you can't bring it though. So if I get a question like this, what am I going to also add right below the curve? What am I going to also add right below the curve? What am I going to add right below the curve? Got to put some room for questions. So let's say we've drawn this out, because I can draw this. It'll look worse if I draw it. Well, we have the z-scores. Great answers, Emily. We have the z-scores right here, right? So whenever we get to a question, we're going to, I think Riley's saying it, we're going to put the mean and the standard deviation, the mean of the data, right? So you go to your normal curve right here that you've drawn out, that you didn't bring to the test, and you put 100. Who follows what I'm doing right now? Who follows how you would write these numbers? I can show it visually, but does everyone understand how you would do this? All you're doing is putting the mean at the center and going up and down the standard deviations. Great job, Emma, right there. On normally distributed with a mean of 100 and a standard deviation of 20, I was going to scroll up, but why scroll up when we can just mark it right here? And then the standard deviations are in units of 20, and the capital N stands for normally distributed, and we go right there. So we also make sure everything's highlighted, that it makes sense. And then also the z-score part is normally distributed with a mean of 0 and standard deviation 1, the standard normal curve. It goes to the third. It doesn't reach beyond. Good question, Ryan, right there. It goes 68, 95, 99.7, 99.99, 99.9999, 99.999999, 99.999999. If you think I'm lying, double check my numbers. It keeps going, even more area, but virtually all of the areas contained within 3 standard deviations. Once you get to the 4th standard deviation, it's 99.99, which is a fun thing to remember because it's 4 nines. Easy way to remember that. And you can confirm these numbers just very briefly. If you go here to between, and you go to there, and you go to between a z-score of -4 and 4. Easy one to memorize for the next one is the 4 nines, and there you go, 99.99. So on a z-score of 4, it is 99.99. You don't need to memorize the next one, but that is the next number on the 68, 95, 99.7, 99.99, and it adds 2 more nines until it gets to the 7th, on which it adds 1 extra 9. And then it has 7 nines after the decimal, which is a fun fact too. I love memorization. I don't know, I really do. I think it's fun. It's fun to just fill your head with numbers. That's what I do. That's why I teach. I like math. I like numbers. I like remembering things. Eventually, we're gonna start forgetting things, right? So here we go. We've set up our problem. We've set it up for success, and now let's look at the question. What percentage of people would have an IQ above 100? Okay, so I want you to start solving these. Put question 1 answer in the chat. Put question 2, just start solving these. We don't need to write the preamble to it. Some of these are easy. Like, those are easy ones. Like, those are... This one's gonna be tricky. That one's a bit ridiculous. Or I did below 140. 140. I'll into that last one. Yeah. I chose the mean. Okay. Okay. So the answer to the first one right here is what percent is the test mostly fill in the blank? Multiple choice, fill in the blank, true, false, just like Canvas content. Check out Canvas contents. Good question, Harrison, right there. So what percent of IQs? Really? I lost my graphic. What percent of people have an IQ above 100? We're going to do the answers in a nice light purple. And it's easier when you can draw it out because above 100 is going to be right here. And then we're just going to go above. And that's above the mean. It's not listed here, but that's half the curve. Now, below 80. Ooh, careful. Up here, we're getting below 80 wrong. Below 80 is what? Below 80 is what? No one's got it yet. Riley's got it. So if you graph it, and we're doing purple answers today, you want to draw this out. Now, it looks like a lot if you have everything drawn out right here, but the answer is 16% because this is the middle 68, and then you go here and do 16% on either side. Does that... And then Adeline has done another way, which is adding together all the parts to it. So good work right there. Any way you solve it, it's a win. You just have to make sure that you get a solve that works and you understand how you're getting it. The more solves you can do, the better. Let's put the 90. Oh, I put these on the wrong numbers. Something looked a little off. That's maybe... Very sorry about that. That should be 16%. It's a little hard. The curve's all... That's 16. And that's 2.5. And that's 0.15. Sorry about that. And... Okay. So for the next one, the answer to that last one was 16%. How about answer 3? Answer 3 is a lot easier now. We are currently doing answer 3, and we just figured out answer 2, which was 16%. You don't even need to really draw this one out because it's going to be easier to get the answer of above because we just did the other one. What is the answer for the above? It is 84. Great job, Riley. And it'll be 84 because we already found out 16% is below, so they have to be complements. Good practice, good answers. Don't worry if you're getting it wrong. Remember, you're here to practice. That's the whole point. Because logically, these two answers must add up to 100 because you're going below a point and you're going above a point. So logically, it has to be 100% of the area. The next one's a bit easy too. If you draw it out, it's very easy to see. What is the answer to question number 4? Question number 4 is an easy one. Only made it a little bit harder towards the end here. It is 68. Riley on fire right there. Great job, Riley. It is 68 because you are merely going between here and between here, and you're just doing the middle 68% of the curve. So that's got 68% right there. How about the next one below 140? So what is going to be the answer for below 140? So I'll start drawing it once people start answering. Take guesses. But what is the answer for below 140? Take a guess, and I'll start answering it. Below 140. Make sure it's below. Riley on fire. You are right, Riley. Yep. And it might be hard to see, but that traces down to here, which means above here is 2.5, and that means we're looking for the area below. If anyone wants to put the math in the chat, you can maybe see it, but we're looking for this area right here, which is a lot of the curve. You could start adding up all those individual numbers, but pretty easy solve if you simply do 100 minus 2.5. The 2.5 is there, which written in my horrible handwriting is up there. And you can see it's 2.5 because it's both those areas added up. Also, it's the area outside of 95 on one tail. So the answer is 97.5 or 100 minus 2.5%. And the area below 40 is way down here. So what's the area below 40? You probably can see it visually. The area below 40 is what? The area below 40. Riley's already got it. Boom. When you visualize it and you do this, it's just that area, and there it is. So that is 0.15. Now the next one, you can actually get it pretty darn easily, because who knows the answer to the next one for 1,000 points, and we're going to end off stars here after this in a moment. What's the answer to the last one here? Let me save the notes. The last one is one of, I don't know if we've ever done this area. It's a pretty ridiculous one to get. Riley, close. Very close, Riley. Close, Riley. It says between. Emily for 5,000 points, and Nancy got it. It's going to be from here. And notice, it kind of looks like the area below 140, except for what? Talk about the mathematics on this, because we've already solved some answers. It kind of looks like the area below 140, but what? I don't know if that's a good visual. It kind of looks like the area below 140, but what? Because it kind of looks like the area below 140, except for we don't include the 0.15. So it'd be 97.5, which we already found below 140. And then we subtract off the remaining 0.15 to get 97.35. That's a little bit ridiculous and goes down to decimal place accuracy, but 97.35. And I'm glad you see it right there. And once you visualize it, you're like, oh, this is 97.5. And then you would subtract off this tiny little bit here of 0.15 because we're doing the between area between these two numbers. Yes, exactly, Nancy. Great job. And is it who feels better about these now? Like if you get to an empirical rule question, I just want you to draw it out immediately and be like, psh, exactly 0 to 140 would be 97.5 or below 140. And 0 is kind of the logical bottom IQ or the lowest. You can't really, I think IQs, they really only go down to like 30, 40. It's at that point a lot of developmental issues and things like that with IQs in that range. So frankly, it's a good Simpson episode on it, how like the world is built for like normalcy. The world is built for the center of the distribution. I mean, it's how you just usually do things. Fun episode from like season 5 or 6 where Homer becomes extremely intelligent. So it's, if you ever see it, it's just, Simpsons used to have a lot of heart to it. Simpsons used to pull at your heartstrings a little bit. Homer just, he's like, and he has has anyone seen that episode? Feeling Way Better, Bridget, I like that. Has anyone seen that episode besides me? I don't want to put some spoilers out there, but the conversations between Homer and Lisa on that episode, especially the end when she hugs him. Go watch that episode if you haven't. Earlier Simpsons episode if you want to see some good animated television. With that, we're going to end off right here. We'll be back later. Bye for now, everyone. Bye.
Hey Brian, what's up?
Hey, Adam.
Oh, what's this?
Adam, what are you doing? Adam.
No! Guys, I'm Jason. Brian's gone. I don't know. I don't know. Just go to Kahoot. We'll get this figured out. He sent you the information. It's on Canvas. It's on YouTube. Just go to Kahoot. I don't know what we're going to do, but we're going to figure this out. It's going to happen. That's all I got. Just go to Kahoot. Thanks. Ugh.